All right, so 3.8 is transforming polynomial functions and their graphs. So we are going to be writing out some rules, and then we are also going to be graphing, and we are going to be using our graphing calculator for some of this. So the first thing we're going to look at is our chart, and this should feel very familiar to you, okay? Because this f of x notation here, those are all the rules. If it's a vertical translation, that plus k is outside. And then look, they even give you some examples. What it looks like when it goes up, what it looks like when it goes down. Notice for the horizontal, you have that minus h. Do you guys remember what minus means besides subtraction? Opposite. Okay, so when it's opposite, then in this case it won't be down. In this case it's going to be right or left. So notice, if you have minus 2, that means it's going to the right. Okay, because you're plugging in a positive 2 there. Okay, and then if you have a plus 1, that's when you're going to the left. Because when you plug in a negative, here you have minus a negative, which simplifies to a plus. Okay, the vertical stretch or compression, that's on the outside of f of x. Remember that we know it's a stretch if the a value is greater than 1. And then, do you guys remember what the a value has to be for a compression? Has to be less than 1, but also greater than 0. Okay, and then when you have a horizontal stretch or compression, you have 1 over b. So remember, when you're identifying what that factor is, there is the reciprocal there. So look, if it's 1/5, this means it's a stretch by 5. If it's 3, it's a compression by 1/3. Okay, this is also the one where if you were to simplify, there are multiple ways that you could say this. Because what happens if you simplify 3x cubed? Do you guys know what 3x cubed simplified is? Yeah, 27x to the third. Okay, so this is also a vertical stretch by a factor of 27. Yep, because this is what's on the outside here, the 27. Okay, and again, that's just the review. So if it looked like this, you can just say the compression by 1/3. I just wanted to remind you that these are the ones where they could have multiple names. And then of course we have the reflection. So a reflection can be applied to the outside of f of x. And remember, I remember that by thinking xo, xo. If it's across the x, it's on the outside. And then I remember if the negative is applied to the inside, y and I rhyme. So across the y-axis, that negative would be inside. And those are just a couple of things to help me remember where it's going to go. Okay, so today we're going to focus on the graphs and we're going to focus on the equations. Okay, so the first one says, for f of x equals x cubed minus 6, write the rule for each function and sketch its graph. Do you guys remember what a rule is? It's really just another way to say to write the new equation. Okay, so write the rule means you're going to be writing an equation, a function. Okay, so the first thing I like to do is assess what's happening. If I have f of x minus 2, then I know that this is being translated vertically. So this is a vertical translation. 2 units down. And that's really going to help me when I'm graphing. Okay, there are going to be multiple ways that you can graph these, so we'll go over the different ways. And then when you're writing the rule, all you have to do is plug in your f of x expression for f of x. Okay, so g of x equals f of x minus 2. Okay, so f of x is this expression, x cubed minus 6, and then we're just going to subtract 2. So this is where you are plugging in this entire expression. And I always plug it in with parentheses just in case there's something I need to apply, but there's nothing in front here that I'm going to have to distribute, so I can just combine my like terms here. So I'm going to get g of x equals x cubed minus 8. Okay, and that is my rule, and that is what I'm going to graph. Okay, so when I'm sketching my graph, I'm just going to make a table for the original function, and then I'm going to translate. And I'm fine if you want to use your graphing calculator to make that original function. Okay, so this is, my table is going to be x and then f of x. Do you guys remember what the parent function for x cubed looked like? We're going to look at it real quick. Okay, so for x cubed, you don't have to write this part down, but if I were to do an f and an f of x, and I did -2, -1, 0, 1, 2, if I plugged in -2 and cubed that, I would get -8. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. Okay, so if I just did a quick sketch of what that looks like, 0, 0 would be here, -1, -1, +1, +1, and then 2, 8, -2, 8, okay, and then this is how you draw a cubic function. This side curves up. What does that look like? Doesn't it look like half of a parabola? Okay, and then it's the same thing here, except it's going down. Doesn't that look like half of a parabola? Yeah. Okay, so that is your parent cubic function. Okay, so when we do the graph for this, like I said, I'm fine if you use your graphing calculator. Let's do that together. So your f of x is this. Okay, so I'm going to graph x cubed minus 6. And then, and you can look at the graph here. You can also just go to your table. Okay, and I am going to graph from -2 to 2, just like I did with the parent function. So -2, -1, 0, 1, 2. And, so for this, I have -14, -7, -6, -5, and 2. All right, and then before I do the graph, I'm going to do the new graph, right? So if I have x and g of x, if it's just a vertical translation 2 units down, all the x's are going to stay the same. What happens to all the g of x's? Well, the translation is just 2 down, so what am I going to do with all my y's? Just do -2. So this would be -16, -9, -8, -7, 0. Okay, you could also just graph the points and then go 2 down from each point. That would be fine. All right, if I'm going to make it down to -16, I'm probably going to want to go by 2's here for the y. Okay, but I only have to go up to +2. That's my highest point. So here's my y, here's my x. Okay, so I'm scaling my y's by 2's. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Now just because I scale my y's by 2 doesn't mean I have to do that for my x's. So my x's I am going to keep by 1's. So like this would be 5. This would be -5. just give a couple for each. I wanted this here so that, because I know I'm plotting a lot in this area. So if I do -2 down to 14, okay, and then -1 down to 7. So if this is 8, this will be 7 in between. Okay, and then I have 0, -6, 1, -5. So again, that's my in-between because I'm going by 2's. And then I'm at 2, I'm at 2 here. And then we're going to plot the points just like we talked about, or connect them. So I'm going to curve this side up. I'm going to curve this side down like a parabola. And then like I said, if you can use this here as your guide, you can also just say, hey, I'm going to take all the points and I'm just going to go down 2. So at -2, I'm at -16. At -1, I'm at -9. And remember, I made each unit 2, so I'm just going down 1 unit on my graph. And there you go. And these are going to overlap because these ends are going to overlap each other. Okay, and then we're going to do part B. So first let's identify what the transformation is. So if you have x plus 3, notice it's inside the parentheses, so that means it has to be some type of horizontal transformation. So what is this? A horizontal translation where? Yeah, 3 to the left. Okay, so we do have the same f of x. So if we're going to translate the graph and we're going 3 units to the left, think about what we want to do there. Okay? We are going to write the rule. So the rule is g of x equals, and then look at your original equation. See how this is x to the third minus 6? So this is x to the third minus 6, except what are we plugging in for x now? What gets substituted in there? X plus 3. Yep. Okay, now, when you do this, you are going to have to simplify this, because we know how to do this now. X plus 3 cubed, you'd have to write it out 3 times and distribute, or you can use what? What's the other way we can expand binomials? We could write it out, FOIL, distribute, or we could use what? Yeah, Pascal's triangle is going to be so much quicker for this. Okay, what's row 3 of Pascal's triangle? 1. Good. Every row starts with a 1. What's the second letter or number? 3. So it's 1, 3, and then 3, 1. Okay, you could look up your triangle, or you could make it. But then the reason why I'm telling you this is going to be quicker is because look at this. It's just x. So this is just x to the third, x to the second, x to the first, which is x, and x to the 0, which is just what? 1. So see how quick that is? And then 3 is going to be the same thing, right? Because what's 3 to the 0? 1. 3 to the first is 3. And then I would just simplify these right now. What's 3 to the second? 9. What's 3 to the third?
27.
Yeah, so see how you can just do that in your head? Remember when we did that? 3 to the 0, 3 to the first, 3 to the second, 3 to the third. And now you just multiply straight down. Okay, I just put multiply. I'm going to write it out over here so I don't have to write it out 100 times. So this would be 1 times x cubed times 1, which is x cubed. 3 times x squared times 3, which is 9x squared. 3 times 9, which is 27x. 1 times 1 times 27, which is 27. Just don't forget that now you have the minus 6. So you are going to just combine your terms. Oops, sorry, this guy was h of x. h of x equals, so x cubed plus 9x squared plus 27x plus 21. So again, if you wanted, you could plug this into your graphing calculator and you could find your points using your table. That's perfectly fine. Okay, you can do that. Or we can think about the transformation, right? Because if it's a horizontal translation 3 units left, what's the only thing that's changing? If you're going 3 to the left, what part is changing? Your x. What do you have to do to all the x's? Subtract 3. So wouldn't that be really, really quick, especially because you already generated these? Okay, so if it's a horizontal translation, 3 units left, okay, all you would have to do is subtract 3 from those, and then these are going to stay the same. This is negative 14, negative 7, negative 6, negative 5, and 2. And again, you could do this right on your graph. So negative 2 minus 3 is negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. And then 2 minus 3 would be negative 1. Alright, so we're going to make our graph. Got my 2. I'm going to do the same thing. Negative 2, negative 4. Negative 6, negative 8. Negative 10, negative 12. 14 and 16. Okay, and then I have my original, my f of x. So negative 2, negative 14, negative 1, negative 7, 0, negative 6, 1, negative 5, and 2, 2. And I curve it, and I curve it. So when I say you can also just do this from the graph, you can just go 3 to the left. 1, 2, 3. There it is, negative 5, negative 14. 1, 2, 3. Negative 4, negative 7. 1, 2, 3. 1, 2, 3. And then 1, 2, 3. Okay, and we curve the first one up, we curve the first one down. Okay, and then we'll take a break from the graphing. Let's do one of our rules, because these are with the reflections. Okay, so one of the reflections, the negative goes inside, the other one goes outside, so let's look at that on the next page.